Machine learning models have zero value if they just run on our computer. Unless we let people use it and show it to the world, all that time invested with training the model and tuning the hyperparameters will just go to waste. Hello and welcome back to my Applied Data Science channel. My name is Joanna, I'm a senior data scientist, and in this video we are going to build a web application. This is the last step in our first machine learning project where we built an apartment price predictor and then wrapped this model and deployed it as an API in the cloud. So today we are going to build the user interface that is going to call this API. To build our web application, we are using Streamlit, which is very intuitive, accessible as a Python package. It is very easy to use. It has a free tier and also very nice documentation. Then publish the code on GitHub. We are going to connect to our machine learning API that we deployed in the cloud in render in the previous video. And then we are going to deploy the web application and learn how to handle sensitive information like API keys, passwords, and so on. I've sketched here the structure of our application. So in order to predict the price of an apartment, we are going to need the specifications of that new apartment, and therefore we will need to ask the user to pass in that information. First of all, we have all the fields that are required in order to predict the price of an apartment. Then we can also add some optional fields just for impression, because probably we don't want to offer full transparency in which is the information that we are using in order to predict the price. For that reason, we can also add some additional fields that we didn't account for in our model. Then we'll have a button. And by clicking it, we are calling the API. So inside that request, we are going to pass in all the values that we've collected from the user through the required fields. And then we are going to return the response, which is actually just the response from our API. We are starting with creating a new repository on GitHub. So for this, we are just pressing new here. And the repository name is going to be Price Predictor UI. We are creating a new repository for the user interface because I want us to keep things separate. So whenever I'm going to change something in the code regarding the user interface, I don't want to redeploy the API as well. So we've already deployed the API that's running nicely in the cloud, and now we just want a repository where we need to keep our user interface related things. And we are going to make it public and add a README file as well that we are going to fill in later individually. And then we are going to create this new repository. The next thing that I'll have to do is clone this repository in my computer. So I'll just copy this link over here. Now I'll open the Visual Studio Code, and inside Visual Studio Code I'll have to open a terminal and then just use git clone in order to clone my repository at the desired location. I'm going to change the directory where I'm working. And then inside this folder I'm going to git clone my repository. Now I can open this folder, which already exists in my repository at the specified location. Here I have my Price Predictor UI. I'll select that folder. And now I see that I only have a README file inside it. I'll open a new terminal. And now I'm going to try to modify this README file and then test if I can push to my repository without encountering any problems. So this is just going to be some test push. Okay, so I've modified the README file, and now I'm going to call a git status to check the modifications, and indeed the README file is modified. Then I'll add this file to commit, and with this I can use git commit and then add a message like test push, because we are just testing that we are able to push and we have all the permissions to do so. And then with git push we can check in our Git repository if inside our README file we have the modification. Okay, so indeed we are able to push to this repository. That was our first test. And now what we need to do is, first of all, create a virtual environment. And this virtual environment we are going to create with Python using the module venv. And now we are calling the virtual environment apartment predictor UI. So this is going to be the name of our virtual environment. A new folder showed up inside here. The next step is to activate our virtual environment, and for that we are going to just give the path towards this activate file. So we are just going to provide the path, and this has activated the virtual environment, where we will have to actually install all the packages that we need. And the first package that we are going to need to develop this user interface is Streamlit. Now we can create a file inside our folder, a Python file, which is going to be called UIPY. So here we are going to build the application. We'll put it in the folder price predictor. And the first thing we are doing is importing Streamlit. And now let's give our application a title, a header, let's say market prediction, market price prediction, app. Let's say app. Just to see how simple it is to actually run this user interface, we just use Streamlit run, and then we pass the path to our user interface file. Okay. And what's happening now is, check this out, we can already see in our local host a user interface. So now what we'll have to do is actually start building all the fields that we are requiring the user to provide values for, and then implement the button logic to call the API, and it's going to be that simple. Instead of saying Streamlit write, let's say Streamlit header. Now let's just start building the fields that we are going to require the user to pass in values for. And the first is going to be the drop-down menu with the neighborhood. And for the neighborhood, we need a list of all the neighborhoods that are present in our database. And I've actually created this list, and I'm copying it here. In order to create a drop-down menu in our Streamlit application, we are going to use the Streamlit select box. And in the select box, we need to first choose the label. The label is the text that's going to show up indicating the user what to input in that particular field. So we'll say neighborhood. And then the options are going to be all the values that we have in our list. Okay. And now let's refresh our application. Okay, options actually. Okay, so we will refresh our application. I forgot the S. And here we have our first field, which is a drop-down list containing all the neighborhoods that we have in our data set. In order to be able to use the value that the user is going to select here, we'll have to treat this field as an object and store the selected value inside this object. So we'll just call it neighborhood. And then we'll go on with the second field that we are requiring from our user, which is the size of apartment in square meters. We are going to store it in an object called apartment size. And for this, we'll have to use number input. Okay. And we have this option, number input. And inside the number input, again, we'll pass in the label, which is going to be size in square meters. And now we don't have options because we'll just pass in a single value, a numerical value. So we can set the minimum value. The minimum value should be the lowest value in our data set. So let's say 30 square meters. And also a maximum value that the user can pass in, which can be, for example, let's say 100 square meters. And then what we can also input is like a default value. I'm checking the documentation to see exactly how can we set this default value. Okay, so there is the parameter value. We can set this to be 50. We save our Python file and then refresh our Streamlit application, and we see that here is the label that we specified, size in square meters. Then we have here the default value 50. And then we can either use these two buttons here to increase or decrease the default value until the value that we want, or we can just type in directly the value that we want. And we see here that when adding 30, there is no possibility to lower that value even more. We also need the number of rooms the apartment has. The number of rooms is going to be also a number input. Okay, so the label again is the text that we want the user to see, or this is how we indicate the user what exactly to input in that field. So we need it to be descriptive and clear. Okay, let's say number of rooms. Then we can choose a value, a default value. Okay, then we'll specify the minimum value, and here the minimum value is 1 because there is no possibility to have an apartment with less than one room. And the maximum value, we can set it to be, for example, 4 or 5. That's up to us and up to actually the data set that we've worked with. And once again, we save the notebook, or we save the Python file and check that the new variable has been added here. And we just go onwards with adding all the fields that we used for prediction. Now we have all these variables that we are using to predict the price of an apartment. But besides these, we could also ask for additional variables that would somehow not give so much transparency into what goes in our model. For example, we could ask what's the floor on which the apartment is. Is it ground floor? Is it first, second, and so on? Or, for example, another thing we could ask is whether the apartment needs renovation or not. As well, in the fashion of a drop-down menu with predefined fields. For example, we can also ask what's the energy certificate of the building, A, B, or C. So these additional fields we are not using per se in our predictive algorithm, but it somehow protects us from the user knowing exactly and having full transparency what our algorithm or based on what our algorithm makes its decision. I'm going to add one of these variables, whether the apartment is passed through or not. Given that I'm not even using this information, I might as well not put it inside an object, but I just want to do it so for consistency and for clean coding. Okay, so let's see, checkbox. And for this, I'll have the label, which is the apartment pass through? The value is false. And now let's refresh our page and see exactly how it looks like. So, is the apartment passed through? If you check it, then the value is going to change to true, and then the pass-through object will have this Boolean value true. Otherwise, it's just going to stay false. Now let's create our button, which is going to calculate the price of the apartment. For this, we are going to use st button. And to this button, we are going to provide a label again. And this label is going to be calculate price. Not rice. I'm hungry. Okay. So I'll call it calculator. Very okay. Save, and let's see if our button shows up. So now we have this button here, which is calculate price, but for the moment this button doesn't do anything. So now we'll have to implement the logic behind this button. So if our button calculator is clicked, then what should our application do? So first of all, our application should collect all this information that the user has input and put it in a dictionary, and then send that dictionary inside a request to a URL, which is the URL to our API. And then also print on the screen the price of the apartment. That's the result coming from the API. Okay, so the first thing that we are going to do is to put all this information inside a dictionary. So we'll have key value pairs, and the keys of the dictionary must be exactly as required by the API. So Previously, we've sent a request with Postman, previously meaning in the previous video, and we've sent this request to a particular URL, and inside the request we have these fields: rooms, size, bathrooms, neighborhood, year built. So these are the fields that are that must be input or must be sent to our API in order for it to be able to generate a prediction. And if we send this correctly, then it will return another dictionary where the key is the price and the value is the predicted price, which is the price predicted with our model. Okay, so let's just copy this dictionary, and then instead of inserting these hard-coded values, we are going to pass in the values that we've saved from the user. So we are going to pass in all these objects. We are going to call this dictionary input values or input data. And now, instead of passing a particular value for the room, we are going to pass the value, or we are going to pass the object here, which stores the value. So number of rooms is going to be nothing else than whatever the user selects here in the number of rooms. So in this case, it will be 2. Then the size of the apartment is going to be stored inside this object. So we'll just pass the object inside here as a value. The number of bathrooms is going to be this object. Then we'll have the neighborhood. And the neighborhood is going to be the value selected by our user as the neighborhood. Let's provide a better visibility. And then the year the building was constructed in is going to be stored in year built. So now we have this input data. And then the next thing that we need is the URL to which we send these values. We are going to paste it here for now. In order to access the URL, we can go on render, where we've actually deployed our model. And we see here that we have our price apartment API that was deployed 9 days ago. So this is the API. And we want to copy this link over here to which we can send the requests. And if we compare here to what we've used in the Postman application, we see that we have a /predict, because that's exactly where we can send our request. So besides this link that we copy from here, we'll also have to add a /predict. And that's going to be our URL /predict. So if we send a post request to this URL with this particular input data, then we should get a response, which is in the type of a dictionary, where the key is the price and then the value is the predicted price. In order to send a request, we are going to have to install the requests package. Let's open a new command prompt, and inside the environment we are going to pip install requests. We'll just import the requests package. Okay, and now we can create our request. So from requests we are going to use a post request, and we are going to input the data that we've collected from the user and send it to the particular URL. So we'll just create an object called request. We can send a request to our API, which is deployed in the cloud, and we will get a response, and the response is going to be stored in the object req. Just say it, result. Okay, so we store it in an object called result. Now I want to show you what the object contains. So what's actually this result? Good. Our Streamlit application is still running. Okay. So let us just leave these default values and then press calculate price over here. And we see that our application is now running, right? So if we only print the response from our API, what the API is returning is the response code. So 200, it means that the request was successful and that the API returns a value, a predicted price successfully. In order to access that particular value, we'll have to run the JSON method on our result, and for this we'll have to also pip install JSON. Okay, it's actually pip install JSON lib, not JSON. And then after running pip install JSON lib, we'll be able to import JSON, the JSON package, extract the price value, so the value but not the key. So for this, we are going to extract the value inside the key price. Press calculate price, and here is our price. Okay, so now we can format this price a little bit just to look nicer. Okay, so this is our application and currently it's running locally. So we have the market price prediction application. We have all the fields that are required in order to predict the price of an apartment and some additional field. Then we have implemented the logic behind this button, calculate price, which is nothing else than a call to our API, which we've already deployed in render, so it lives in the cloud. The next step is to move this web application from our computer, from the local host, to a cloud. So we'll have to also deploy this web application. And in order to do so, the first thing that we'll have to do is to create a requirements file. To create a requirements file, we are here inside our virtual environment, and by using pip freeze and then passing in the name of our requirements file, we'll say UI requirements.txt. We'll create a file which is called UI requirements.txt, and inside this file we have absolutely all the packages that are needed for our web application to run. There are some things that we don't want to push to GitHub, so for that we will create a .gitignore file. And inside this gitignore file, we are going to put, for example, our virtual environment. So we'll provide the name of our virtual environment. And something else that maybe we don't want to provide is this URL over here, assume that, for example, we don't want people to see which is the address to which we are sending our requests. So we don't want to see exactly where our API is deployed. And this might be because, for example, Render being a free service, it requires the API code to be public on GitHub. So probably we don't want our code to be visible to the users. So instead of putting this URL here with this code that's also going to be pushed publicly on GitHub, we want to protect it in some way. And for this, we'll just have to create a new folder which is called .streamlit. So Streamlit. So this is going to be a hidden folder, and inside this folder we'll create a file called sectrets.toml. Okay. And inside this file, I'm going to actually place my URL to the machine learning API that I've built. So let's copy paste this URL here. And now I'm saving this. Instead now of just placing my URL here, I can do something which is use st.secrets. So in the package Streamlit, I'm going to say st.secrets, and from st.secrets I'm going to use the API URL and I'm also going to put .streamlit in my gitignore file such that it will never leave my computer. Okay, so let's test once again that our application runs smoothly even when we've changed. Okay, so API URL is not defined. Okay, so let's check exactly why that happens. So we have the secrets API URL, and okay, and now I'll have to use the quotation marks. So this would be one way to do it. Let's see if this works, and otherwise I'll have another idea anyway. Okay, so now our application works. It runs, and also our URL is not visible to the user. So the next thing that we'll have to do now is to push our code on GitHub. Okay, so let's see exactly how to do that. So we are in the price predictor UI. The first thing to do is call git status to see everything that we've changed and everything that's going to be pushed to our GitHub repository. Okay, so we are pushing the gitignore folder, the UI.py, and the requirements. And this is everything that we've modified. And now we are going to add all these files and use git commit with our message, which is v1 functional UI. Okay, and now we run git push. Let's also check that here in the user interface. So now we have our UI and UI requirements. Okay, so now the next step is to deploy our application in Streamlit. And for that, we are going to log in to Streamlit or create an account if you don't have one already. And here we are going to press Create App and select Yes, I have an application. Here we are going to select our repository. So we'll say predict price predictor UI, the branch main, that's okay, and then what's the main file path. So the main file path is ui.py. Okay, we already, this is basically where we've written all our code. Let's go to advanced settings, and here, as you can see, we can select the Python version, and we are using 3.12, and then the secrets. And because we haven't uploaded our secrets file, respectively our API URL, to the Git repository, we'll have to provide it here. So API URL equals, and we'll have to provide the exact link that we have here in our local file. Save. Okay, everything's fine. Okay, and now what we have to do is just press deploy, and now our application is going to be deployed. Okay, so let's see if this is working. Just press calculate price. Yay, it's working. Let's change the neighborhood to Grigorescu. Let's increase the size of the square meters. Let's say it has 3 rooms and 2 bathrooms, and it was built in 1985, and say it's not passed through, and then calculate price. Okay, cool. So our application is working. So this is our application, right? So we can access it from our Streamlit account. But there is this share button over here. And with this share button, you can either invite people to check out your application. You can make it public or private. And you can copy a link here. So then if you'll share this link with your friends or whoever you'll want to check into your application, you can do that. So for example, what I'm going to do is improve a little bit this user interface, add some more fields, and then maybe add also a feedback button. And I'm going to share this application inside some Facebook groups where people are selling apartments. So there are those who sell apartments and those who buy. So I want to ask them what do they think about this price predictor tool, if they find it useful or not, if the predicted price is what they are expecting or not. I really hope that this video has taught you something new and that you are now feeling motivated and equipped with all the knowledge to go beyond just building a machine learning model, to wrapping it into an API and even build a simple user interface. So add tangibility to your machine learning models and convert them to some purposeful tool that people can use and play with. If you've enjoyed this video, or if you've enjoyed overall the entire journey from start to end with our apartment price predictor machine learning project, I invite you to subscribe to my channel, and you will be notified when I'll post more applied data science related content. I have big plans for this channel, and we are going to continue building machine learning projects, so stay tuned. See you next time!